In this episode, we talk with Patryk Laurent, CEO of Scenera, a video AI company focused on safety, security, and building intelligence. We discuss how cameras can act as smart sensors, why edge computing matters for privacy, and what an IoT renaissance could look like. Patryk also explains how Scenera uses AI to detect real-world events, from falls to loitering, and turn them into useful data.
Welcome. So today we have Patryk Laurent, CEO of Scenera. Welcome to the program, Patryk.
Thanks, Hunter. Thanks for having me on.
Absolutely. So just to start, let's give us a little background on yourself.
All right. I would say I'm a highly technical executive. I recently became CEO of Scenera. My background is in software development and big data neuroscience. So I have a PhD in cognitive computational neuroscience, but I started programming when I was 6 or 7 and have been doing software development throughout, my whole literate life, I would say. That's been sort of a secret weapon of mine throughout my career. And then I have been in industry. I've worked in a variety of fields, verticals that use AI and machine learning, worked in robotics, smart home, consumer electronics, and currently now I'm working in a safety and security video AI company. So we can talk about that perhaps later. Yeah.
Very good. And you spent some time with a PE firm as well, right? Can you talk?
Yes, I did indeed. I spent about 4 years along the way at a private equity firm creating and running a center of excellence for data science, disseminating knowledge across companies within the portfolio. So fantastic experience. Really got into going into a company, understanding the technical challenges and organizational improvements we could make, and then really just helping them improve the value of what they were producing, adopting the latest emerging technologies where appropriate. Fantastic experience. Yeah.
Yeah, I'm jealous of that. That sounds really interesting. All right, so tell us about Scenera. What do you do? What does Scenera do?
Okay, so Scenera is a company they started a while ago, back in I think 2017 actually, as an R&D company for Sony, Nikon, and Wistron, these camera manufacturers. So Scenera is doing advanced camera R&D, looking at how data could flow across cameras and between central servers, et cetera. And co-founded by the creator of the HDMI specification and DVI before that, if you remember DVI, that wide, yeah. So his company was the one that did all that. So this was a company he formed later. And about 3 years ago, after generating a bunch of IP around cameras and smart cameras, they decided to go commercial and become an AI company. And that's when they brought me on board. I joined as their chief science officer and I started consulting at first, and they brought me on, and then eventually I became promoted to CEO last quarter. And so we provide a video AI at an edge platform that lets you use your existing cameras to provide safety, security, and intelligence on how space is being used to improve your building operations, et cetera. So really targeted at commercial real estate, facility management, and office buildings, multifamily housing, et cetera. Yeah.
Okay. So I do want to I want to drill in and learn a little bit more about what that means in terms of what kind of value the product brings to. It sounds like property managers, building owners, that kind of thing. I think there's a security component to it as well, or is it? But it's about efficient use of space. Can you drill one level deeper in terms of like what kind of features that this platform has?
That's absolutely, yeah. So what this platform will do is, we'll install a device in the building or in the buildings, and it will connect to all the available cameras that they connect to it. And what it will do is it'll provide notifications for important events that occur. So if someone falls down or someone climbs over the fence or whatnot, this will detect that and can send a real-time alert to, say, security staff, right? So number one, that frees up security staff from having to stare at a bank of cameras in some little tucked away closet or room somewhere, right? They can walk around and be more present. So that's one of the primary use cases, is around security. But safety is another one. So detecting whether there's someone falling down or an object that's left behind somewhere. An unattended object is a very common one. One we're looking at right now is spill detection. So if someone spills something, we want an alert. Turns out to be a challenging one, but
Well,
we
right, yeah, liquid is it's like hair. It's very, very difficult, right, to kind of model liquid and wind and some of these other things, right? Is that what makes it challenging?
Yeah. I mean, we can get into it for sure. The convolutional neural networks that we use for this type of thing are based on texture patterns, and most liquids don't have a texture pattern on them, so they're tricky to detect. So we're using other AI methods to do it. But we can get into that for sure. But so in terms of the way it's used is notifications, like real time, to the person who needs to get them. And then there's also more of an analytics component where data that gets collected by this video AI lands in a big data lake. And that data lake gets all organized, and data is temporarily accessible with the right kind of time alignments and everything. So you can look for correlations or understand what's happening with the data over time. And so that's part of our service as well. So there's the real-time component, the sort of data lake component as well. And then, as you can imagine, you can put LLMs on top of these to enhance them further.
Yeah. Couple follow-up questions on that. One, you mentioned the use case of someone climbing over the fence. How does one go about, and try to let's not get too technical. I know you and I could probably geek out real hard on this, but like, how does the team go about identifying an event like that? Like, I know back in the day, it would be more about just like setting parameters and seeing if anything came over the perimeter, but then you've got like birds and all sorts of other things. So how does one train a model or build a system that can identify a person climbing over a fence?
Right. So I would say that. So I think older style systems used to be based on motion detection or things like that would trigger detection. Now with modern, vision AI, the detection can be very specific, right? So it can be a person, right? And you can get a very high, even in a darker environment, pretty high detection rate for a person. And we retune, so our system will retune the models for specific locations, so their accuracy goes up over time.
Mhm.
But essentially, it's a combination of reliable detection of the person, and then there is still a perimeter. You still do get a perimeter in there. There's some ways where perimeters can be automatically drawn. We're getting to the point where the setup of the whole system is much less manual than it needed to be in the past. So that's coming.
Mhm.
But yeah, that's it. So it's you're able to our system detects a person crossing a line, and that is essentially what triggers the alert or the data entry into the data lake. Yeah.
Okay. How about someone falling? Because
Mhm.
there's no perimeter there. What
There's
does it
no
look like to predict that someone just fell?
Yep. So we have two approaches for that. One approach, and we do this very reliably. So one approach is based on pose detection. So there are models that will detect the pose of an individual. And so what you'll actually see coming out of the model is essentially a skeleton. It's like a wireframe skeleton, which is very interesting for a few reasons. If you look at that data, you can know what people are doing without knowing who the people are. So it's a very
Mm.
interesting privacy preserving information, right? So if their pose, goes horizontal and stays horizontal, that there was a fall that was detected. In other cases, it's actually possible to train a classifier to tell the difference between a standing person and a person lying down, like a person flat horizontal. So there are two methods: pose based and sort of just object based. You train the system to detect And then crouching is another. You could have a few different poses that you train on. So yeah.
Sure. It's, sitting probably looks a little bit like crouching, and slumped over doesn't necessarily mean they're laying flat. And I imagine it gets very complex very quickly. So switching to the second bit of what you were talking about, which is the analytics bit. Can you provide an example or two of an insight, preferably an actionable insight, that someone might be able to glean from this robust set of data that's going into the data lake from an analytics perspective? Like what could you learn from that
Right.
data?
Right. Yeah. I mean, you can start simple and go more complex. So a good simple example would be, if you've got cameras outside of a building, right?
Mm-hmm.
Have the system detecting loitering, right? So if a person, so loitering means the same person remains in the same location for an extended period of time, right? Which means you have to use a tracker, right? If that person leaves and another person appears, it's not the same person anymore. So we use trackers at the edge to keep track of individuals, even though we're not recognizing their faces or anything, right?
Mm-hmm.
So if you detect someone loitering in a place for extended periods of time, what you could do with your analytics is download all instances of loitering, say over, the past few months, and then pivot table it, right, in Excel, because our system lets you pull it on into Excel, hit the
Mm-hmm.
refresh button, you get the latest data. You create a pivot table, break it down by day of the week or hour of the day, and that might tell you when you need to send people on patrol, right? Just to walk by there, right? To just dispel any people who might be loitering, right? And then that overall improves the building experience for the tenants, the occupants, because it could be even a safety risk depending on,
Mm-hmm.
right? But either
Mm-hmm.
way, that's an example for you.
Okay.
Yeah,
Okay.
yeah, yeah.
You mentioned there might be a more complex example. What would that be?
Right. So more complex examples, you could start to look at the interplay with weather. For example, for every building we service, we capture data like weather, traffic nearby, all this kind of ambient data.
Mm-hmm.
And we again align it temporally with everything else going on. So you can start to look for correlations like, oh yeah, is this happening during rainy weather, right? And maybe that's when I need to look out. Or, maybe people's slip and falls are correlated with rainy weather. So you can start to when you pull data from our data lake, you can start to look for these interesting correlations, and it helps you do that. And I will add, we have an LLM-based approach that we've been developing where it will kind of help you find those correlations. It'll help you look for them. And if you have any policies in your building, it'll bring those into the picture as well. So it's very interesting what you can do with
Okay.
it. Yeah.
Yeah,
Yeah.
that is very interesting. So tell me about what, like, your stack, or like what technologies that are not homegrown are you using, and then what homegrown stuff do you have, right? Are you using off the shelf models that you're fine tuning? Are you training foundational models? Tell me about your stack a bit
Absolutely. Okay. So uh, this is great.
without
So
divulging anything proprietary or
absolutely,
confidential, of course.
absolutely, and we can edit that out, right, if
That's
necessary.
great.
So,
You can.
but yeah, so no, so we are running. So I would consider our platform a cloud managed edge platform, right? So it's all the compute, all the heavy lifting is being done at the edge, on premise, but we manage it all from the cloud. And so the cloud we're using is Azure, is what we're using. And for example, to manage our edge devices, we use something called IoT Edge.
Okay.
It's an Azure-based service that we use, and it helps. It'll deploy Docker containers with the software. It'll update. It'll provide some basic, monitoring of the status of those containers, et cetera. So that's one example of part of our stack. But then, in terms of the data coming back from those systems, and we're not streaming video, right? That's actually one of the advantages of our system. The video is processed at the edge, but we do stream metadata, the results of these AI detections, which is these packets of JSON. And so we have a whole data pipeline set up that manages that at scale, right? You can imagine hundreds, thousands of cameras, right? We have this scalable pipeline that handles all of those. So that's proprietary. We built that kind of in collaboration with Microsoft engineers, but it is proprietary to us. And we have a data format, et cetera, a bunch of APIs around that. Internally, we do use, let me think. Oh, we have to manage the models, the AI models. So we usually start with an off the shelf model, but we have to rapidly fine tune it. The state of the art is that, you put these in an office building and they don't work that well. So you can imagine we have to train per building usually to get really good performance. I'm talking, 99% plus performance. Because if you don't do that, people turn off the alerts. You don't, it's just, they don't become useful.
Yeah.
So to manage all of those models, we have a system built on ML Flow. I don't know if you're familiar with ML Flow.
A little bit.
little-
Yeah.
So ML Flow is a package that was open sourced by Databricks.
Oh, okay.
And we have integrated that into our platform so that every customer's models remain kind of in an isolated registry. And we use that to track all the retraining, et cetera. So we have a hybrid system that integrates ML Flow as part of our stack for.
And so like new versions of models, like it all gets tracked and okay.
And then they get
Okay.
deployed from there. So it's a really nice system. Now you mentioned foundational models.
Mm-hmm.
It's interesting you should mention that we are on the R&D side, we are developing something called an event foundational model. So as you may know, most foundational models will be based on text and certain specific types of text. In our system, we're using these JSON packets, which represent events, right?
Mm-hmm.
Someone entered the building, someone went to the concierge, someone dropped an object, or so all these events are that's what we deal in. And so we're building a foundational model that tells you not about the text, but it tells you about the relationship between events in a space. Yeah, this is going to be really interesting because it lets you create new kinds of analytics. It lets you create new kinds of applications
Right.
in a previously, not really possible way. So we're really excited about that and releasing
Yeah.
that. Yeah.
So I want to take a moment here to kind of talk about a very, very common misconception about AI especially from fairly non-technical people. They often say, and then we train a model to do X, Y, or Z. And very few companies are actually training foundational models. That is the truth, right? Most companies, including Scenera, is using foundational models. And we're talking about folks like OpenAI and Meta's Llama and, Claude and Mistral and you name it. Most companies, even that are fairly deep in the AI space, are not actually training their own models from the ground up. Is that fair?
Absolutely correct. Yeah.
Absolutely.
They're creating prompts, they're creating special types of agent frameworks around these foundational models. Exactly.
That's right. That's
Yeah.
right. But what Patrick just said is that they are, in fact, it sounds like they're working on training an actual foundational model from the ground up. And we're starting to see this. I was just talking to a VC last week about a company that's deployed a tabular model, right? That's exceptional at interpreting basically spreadsheets, because the foundational models, they're okay with the spreadsheet, but there's some like if you input let's say a complex Excel file with pivot tables and all the rest of it, ChatGPT falls down if you were to try to do something like that. So as the foundational models mature, we are seeing like application specific or data type specific, right? Like you're talking about an event based model or a tabular model, so we're starting to see that one level up from foundational text based models, which is basically where we started.
That's right. And just, you can There is an intermediate thing of fine tuning some of these LLMs that, that you can sometimes say, oh, I have a domain, a very specific domain, and you can do some further tuning, right? Which doesn't mean you're creating a foundational model. But you are modifying the weights in an existing model if you have access to it. That is done as well sometimes, although it's usually not, worth the squeeze. Recommendation is to really just get your prompts as accurate as possible. But when you're dealing with a new data type, I think that tables is a great example, the Excel-based thing.
Mm-hmm.
Yeah, it's a different domain. And by having a text-based system, use up all of its context tokens to force itself to work in that domain it's wasteful, and it will not work as well as a foundation model. And yeah, we're doing the same thing with events, right?
Mm-hmm.
If you can intelligently reason about events, that's where I think there's a potential big value. But you need lots of them. You need a lot of them.
Like, yeah, a lot of training data.
Yeah, a lot of training data. Tens of millions of them. Yeah.
Tens of millions. Yeah. And a lot of compute, probably, right?
Yeah.
A lot of compute. And those edge devices need a lot of compute. Are they pretty hardcore, like GPU based edge devices, or?
Yeah. So, I mean, generally we're able to get away with these, there's some NVIDIA sort of devices made for edge processing, and actually Qualcomm ones as well.
Mm-hmm.
Depending on the size of the deployment, how many cameras in the building or per floor that we need to tap into, we'll right size it. We'll get the right size device for that case,
okay,
for the vision. But yeah.
Okay. How big are they? Shoebox?
Yeah, a little, about the size of a shoebox. Yeah. And they have like radiators. I wish I had one right here. I could show you, but they have little radiators on them so they can, emit the heat. So yeah.
Mm-hmm. Yeah. So this is kind of a switching gear topic, a little bit away from the product and the tech. But I'm curious, so this is obviously a very AI literate company. Are you finding that outside of your product, and I'm talking like back office, administrative, sales, HR, are you guys using a lot of kind of large language models or other AI is, neither of us probably love that word, but like any of the newer like tech outside of the organization?
Yeah,
I mean, not outside the organization, outside of the product. I mean,
outside of the product, right? Yeah. There's definitely, I know for sure it's being used for like market research aspects. Well, I know our developers themselves are using it, right? So as a tool, they're not doing the vibe coding thing where you just say, oh, here's my prompt, build it for me. They're doing stuff that's much more targeted. But today, in fact, a developer pinged me and said there was a strange behavior in some new code that was being written, and they thought it was one thing, and then someone said, well, let me try Codex, which is the Copilot one, and it found the problem. I was quite impressed. It was like a concurrency bug, which are notoriously hard to find.
Very hard to find and fix. Well, no, not fix, but find is really hard. Yeah.
I find it. It wasn't a race condition. It was one of those like a concurrent lock. Something was locked, and then something new came in and was using the same lock, so it just blocked itself, right? Deadlock, right? And to me, that's really impressive. That it shows that the material it's exposed to is rich enough that translates into a understanding, or what looks like an understanding of like the underlying threading and concurrency model. So, that was impressive. But then, sometimes you see weird things where it puts a list instead of a queue and it runs out of memory, right? Or something like that. So your mileage might vary. It's helpful though. I'm thinking about other use cases. So yeah, the market research is definitely one aspect. I think that there's also something about customizing outreach. I think like some of the outreach gets customized through LLMs. Yeah. So it's being used here and there a little bit. Yeah.
So for the code, is there one? Do you have the whole team on like one? Is it Codex for everybody, or is it bring your own model situation, or how does that work?
At this point, it's choose your own
Just
model.
your own,
So
right? So you
yeah,
got people using Claude Code maybe, or Cursor, or Codex, and the new release of Codex and Claude Code, I'm told, are blowing minds again, like from last.
certainly. Yeah, I think that I used last time I used Claude was definitely like 2-3 weeks ago for something really small.
Mhm.
So I've definitely not seen the latest myself, but yeah, literally one of our developers used it yesterday, so he must have
Mhm.
been the latest. I will
Yeah.
also say I have a developer who refuses to use it,
Mhm.
who also chooses just to do things himself 100%. So, and that's fine.
And that's fine
That's fine. That's fine by us.
for
He's
now.
very productive. Yeah,
Yeah,
for now he's very
for now.
productive. So I think that's why we're like, okay, but
Right. But the day that, you know, he starts lagging behind where he's half as productive as the folks that are using it, it becomes kind of not fine anymore, right? Like, the productivity has to be there. Interesting. Okay. Okay. So you mentioned this event-based foundational model. I'm interested to hear if there's anything else like in your longer term roadmap. And these days, long term means like 2 years. But like, what's next? Like, what's in R&D right now? Like, what's coming down the pipe that's really interesting?
yeah, I can project out a little bit. I would say it's R&D that I'm watching closely. We're not actively involved in that. Scenera's pretty small. We have a pretty limited, budget for this type of thing. But
Hmm.
one thing I am watching closely is something called, well, it's low energy AI, right? I'm looking closely at lower energy AI because ultimately what's going to happen is right now we're putting a box at the edge. And that's better than the AI that's hard coded into the cameras because it's flexible, first of all, and it can run a richer variety of models. Whereas when you put your video AI into a camera, it's much more constrained.
Hmm.
Performance is not as good. It's not as flexible. So that's why we have these edge devices. But I do think the future is it will go into the cameras themselves,
Okay.
but that'll only happen when the power and it needs to fit into a smaller space and not overheat. It needs to be highly performant, right, and efficient. So neuromorphics is the key word for one of these areas where they're looking at basically optimizing these AI models to run in a very low power mode. So that's one thing I'm keeping my eye on is this neuromorphic approach
Is
because
that
I'm. Mhm.
is that in academia right now, or are people trying to commercialize it already?
It's on the border. It's on the border of that. So yeah, it's emerging from academia. There are companies, venture funds starting to be organized around neuromorphics. IBM actually did a bunch in the earlier days of it and kind of proved the point that you could run these intense networks without generating huge amounts of heat.
Hmm.
They even let us touch the chip. You could put your finger on the chip, and it's like it's running cool, even though it's doing all this compute. And so, I I think it's on the cusp of becoming available in like probably 2-3 years, right?
Is
Yeah,
that? I mean, that's a software solution, like
and it's
like low power model, like inference. Is that
it's
what that
it's
is?
it's it is hardware. It is
It is
hardware
hardware.
based.
Okay.
Yeah, it is hardware based, but I think what we're seeing is the ways to take the software models and convert them into forms that will run on these types of hardware, right? I think that's where the research is going. So that's the advanced R&D that could be really interesting. And it's mostly for inference, by the way, right? It's not for the learning part, it's for inference. Yeah. Yeah, runtime. So yeah, that's definitely one thing I'm keeping my eye on. I also wonder about like if you can have cameras that are intelligent sensors, right? They're doing everything at the edge, and they're power efficient. I mean, is it something you could just sort of put somewhere where you need analytics done, and then it starts reporting over cellular, right? Someone today, in fact, mentioned a case where they deploy concierges to buildings, right? Like a new concierge. And they want to make sure that concierge is standing up and greeting people during their initial 2-week, period, right? And so
Mm-hmm.
they want to put just a camera there temporarily just to get metrics and data on their behavior. And then afterwards they'll take it away, right? So can you make this so easy and so power efficient that you could just put a little camera to track the analytics you need for 2 weeks and then take it away and apply something else, apply it somewhere else, right?
That's interesting because, I tend to think of a camera as a different thing than a sensor. But you're talking about a camera as a sensor, right? You would, just like if you wanted to monitor temperature, you'd put a temperature sensor somewhere and you'd get a stream of data back. But you're saying a camera can be thought of, or a future state of cameras could be thought of as a sensor that is just there collecting data, and it's using visuals as the raw data,
Correct.
right? Versus temperature.
Yep.
But then it's not really the visual itself that's important, but it's rather what's extrapolated from it.
Exactly.
Ah,
Exactly. That's the future, right? The future is, yeah, you just get the data, right? You just know how many people walked by, or, you know, if what types, yeah, are people standing, sitting? How are they using the space? Does it need to be cleaned? Did someone do a good job cleaning the space, right? Did they miss a spot? It's like, imagine sanitizing a space, right?
mhm,
There are all things where, yeah, you don't care about the image. You don't need the image from it, but you do want a bunch of pixels that are being converted into something meaningful for your business. Yeah,
mhm.
that's definitely the future. Yeah, it needs to get cheap enough and low power. Yeah,
You know, I think like the promise of the Internet of Things, if you remember, what was it, 2010, 11, 12, how everything was going to be connected, there was going to be sensors everywhere, and everything would become smart. Never really delivered on that, right? Like, yeah, I've got a smart refrigerator it's useless. Useless. Same thing with my washer dryer, right? There's no reason that there's no value to me for it being smart and connected. And maybe like what was missing was the ability to do a lot of compute on edge devices, or better sensors like cameras that can get much richer information from the environment. Like, do you think we're going to see like a IoT renaissance once this technology comes out?
I think that's a great way to put it. I think that's exactly what we'll see, right? And by the way, I think an important part of that is going to be privacy, right?
Mm-hmm.
The ability for you to have all these sensors, but still keep the data private and process it as locally as possible, right? So that when you walk by your laundry room, if the dryer's done, it will let you know I'm done, right? Like, so, right, exactly like you say, there's going to be a nice combination of awareness of what's happening in the space because the local compute's there, but you also have better sensors, right? And yeah, I think you're absolutely right. There will be an IoT renaissance. Beautifully put.
I love it. Okay. And so just to connect the dots there for other folks. One of the major reasons, I'll call it, that cameras are not used in this way today is privacy, because the limitations on the hardware of a camera mean that we have to send the full video feed, including people's faces and what they're wearing, to the cloud. At which point, then maybe we can extrapolate and anonymize or whatever. But we don't necessarily have a powerful enough compute on the cameras themselves to do all that work.
Yeah.
And that makes them
do it well. Can't do
or
it well.
do it well. And that makes them a very not privacy friendly sensor. But when the power of these cameras to be able to do edge computing in a way that you can extrapolate the data without having to send it out, the visuals, the faces of people, then all of a sudden it becomes a much more viable option that's privacy friendly.
It really does. It really does. And if you think about it, I mean, it helps with all sorts of regulations. If you think about it, if these edge cameras become powerful enough, consider this. Consider the case where you actually did need to find someone, right? So I'm saying it's a private network. I mean, you can imagine like Scenera might in the future, cameras just around buildings might become part of a neighborhood watch kind of safety network, right? But how do you do that without streaming everything to the cloud, faces to the cloud if you're looking for someone, right?
Right.
Well, what you would do actually is you would push the image of the person you're looking for out to the cameras.
Right. Push.
And
Yeah.
then a camera might say, hey, I think I see them, right? Right. So you can still have a safety network without giving up privacy if the
Right.
edge is powerful enough.
If
right?
the edge is powerful enough, because cameras scare people.
Yes.
People don't like cameras. Like if you want to lay down one of those cables in a road to track how many cars drive through at a given point in time, nobody cares. That's fine. Whatever. But if you want to put a camera up on the same road for the same purpose, people care because they know it's getting a lot more information than they really need, nor do they really want them to get. So, and you know what it reminds me of? A lot of people have been talking about this Super Bowl ad from Ring. I don't know if you saw this, the doorbell cam. Okay, they just announced a new project, or I don't know what they call it, where if your dog goes missing, they can activate all the Ring cameras in the area to help you find your dog. Right? And that seems wonderful on the surface. Find lost dogs. Who's gonna have a problem with that? But how far away are we away from find a suspected criminal with a similar network, right? Or or find a car that maybe, we may be looking for something. And so, while on its surface, that sounds wonderful, but there was like an undercurrent of backlash of like, this is how it starts, like surveillance, Big Brother state, like coming in, networks of cameras everywhere. Like this might as well be like a public CCTV at this point.
Right.
Yeah.
Yeah. It's I think there's something about when those things start getting streamed to the cloud and start getting, centrally reviewed and monitored, I think you do have to have a concern there, right? I think there is a concern, and I think the answer is you have to empower the edge. You have to make that edge as secure as possible, as secure as a smartphone, right? No one has that. We're walking on cameras on our phones all the time. People don't have that concern of this is how it starts with their phones, because they know the data is staying on their phone. They know it's not being streamed out constantly, right? So that's, I think, that's where you're going to see the difference is once the brands will, once camera sensors become intelligent enough and they're maybe not even connected to the internet or whatnot, right? Like, who knows? Not streaming everything over the internet. And that's where you might start to see, the future emerge. Yeah.
Love it. I love it. A renaissance of IT. You heard it here first, people. Okay, well, Patryk, this has been really eye-opening. I learned a lot today, and I hope our listeners did too. If anyone listening wants to learn more about Scenera and your products or services, what's the best way? Is it the website, or are there people to reach out to? What's the best way to learn more?
Yeah, we have a website, and also info@scenera.net is a great way to hit some of us, and we can reply with any answers to questions you might have. Absolutely.
Even better.
Yeah.
All right. Well, thank you, Patryk Laurent, for coming on.
Thanks, Hunter. Great chatting with you.